second.
Have you come up against the ambiguous case of the law of signs yet?
Not too much. I'm just not clear about it.
Okay.
Really.
Well, this first example is angle side side. You see why it's angle side side?
Yeah.
Okay. Whenever you have angle side side and this angle is less than 90 degrees, you have the possibility of having an ambiguous answer, meaning there's potentially two triangles that could work. So let's go ahead and I'll show you how you can determine whether you have that second triangle or not.
Okay.
So how do I solve this triangle for starters?
You'd have to do the law of sines.
Okay, go ahead and tell me what to write.
I'm not. I actually don't have. I'm not sure what the law of sines.
Okay, the law of sines is very straightforward. What it says is that in any triangle, the sine of an angle divided by its opposite side is a constant. That never changes. So in other words, I can say the sine of 49 degrees divided by 24 is equal to the sine of C divided by 19.
Okay.
Have your calculator?
Yep.
So let's solve it. So the sine of C is going to be 19 times that. So I get sine of C equals what?
Negative 0.7.
Shouldn't be negative. Shouldn't be negative because the sine of 45 degrees is a positive number. Make sure your calculator's in degrees.
Yeah, I'm not. I don't think it is.
Okay, put it in degrees and let's try that again. Alex, you still there?
Yeah, I'm not sure. One of my friends changed it to degree.
Okay.
And I'm not sure. Changed it back. So.
Here, let me. Fortunately, my calculator still has no batteries in it, but I can pull up online.
Sorry about that.
My online calculator here. So I'm going to take the sine of, wow, hold it.
I got it. I got it.
Good. It's better if you do it, really.
Yeah, sorry about that.
Okay.
I need it in degree.
Yeah. In other words, you want the sine of 49 degrees times 19 divided by 24.
Yeah. Yeah, it was in radians. But
okay.
Let's try y.
Yeah, you want to hit the mode key.
Yeah. 0.59.
0.59?
Yeah.
So what is angle C equal to? We solve for sine of C. Now we still want to solve for angle C.
So divide by C.
Oh. How do we find angle C?
Or the inverse of sine.
Inverse of 0.59, yeah. Inverse sine of 0.59. What do you get?
36.15.
Okay, now here's the trick. That is the primary answer for angle C. And that's the only answer your calculator is going to give you. But we know that there's another possible angle that C could be, right? Because sine of C is positive in the first and the second quadrant. So what is the second quadrant angle, where the sine of C would be equal to 0.59? And the hint is it's supplementary to this angle. So what angle is supplementary to this angle?
Is supplementary to this angle? Is it angle C?
No. Here's what I'm saying.
Oh, angle B, because it splits it up into.
Well, it's, just for the moment, this is not an angle that is necessarily in the triangle. In order to handle the ambiguous case of the law of sines, always figure out what this one is. Now what we're going to do is we're going to add this to the only known angle that we have in the triangle, which is 49 degrees. And because it is greater than 180, this is not a possible solution, and the only solution is the one we just came up with.
Oh, yeah. There's not two triangles, my bad.
Right, there are not two triangles. If I add this second solution to the other known angle and it's less than 180, then we do have both triangles.
All right.
Hopefully we'll find one like that. Although
there was.
Maybe not. I don't see one yet on here. It usually requires this side that's 19 to be greater than the side that's 24. In other words, it's got to be angle side, and this side has to be larger than the other. Okay, and then that's when you need to start worrying about whether there's more than one solution or not. Okay, so we still haven't solved the triangle. All we've solved is for angle C.
Oh, yeah.
What's next?
1 second. Angle C. Oh, we could. Oh, sorry about that. Add 36 and 49. 36.15.
So what is angle B?
1 second.
Must be 94. No. Yeah. 94.85.
Yep.
Okay.
Yeah, 94.
We know this is 19, and we know this is 24, so we've solved for 5 of the 6 pieces of the triangle. And how do we get the side B?
Wouldn't I do...
Yes, you would.
Oh, I could do tangent? Or,
no,
yeah.
no. We need to use
no, I don't
the
have.
law of sines.
Never mind.
In other words, the law of sines
Opposite.
What this exercise is all about.
Opposite and hypotenuse.
So the only thing we need to do in order to use the law of sines is we need one angle and its opposite side. That's that relationship. In other words, the sine of 49 degrees, and it can be either way here. I could put is to 24 as what?
As 94.85, or sine of, that, over B.
Exactly. And that's all for B. And now you've solved, and then you've solved the whole triangle.
Okay, cool.
Okay. Let's go on. I want to make sure we get all of these covered. I'll let you do the arithmetic here. As long as you know how to do that.
Yeah, I can do it.
Okay. Let's look at the second one.
Hold
hold on. Be right. Okay. So the second one, and I'm only going to start with the information that was given to us. Let's see. We got A, B, C. Angle B is 21. Side B is 17. Side C is 32. Notice this is a completely different situation.
Uh-huh.
Oh, no, it's not.
Side thing.
No, it
It's
is.
same thing.
It's same thing. Side angle. Yeah. Okay.
Yeah.
So, how do I proceed?
I guess the same way you do.
So,
Or,
I'll write. You tell me, and I'll write the equations.
alright. So you take the sine of 20, or the, sine of 21 over 32,
No.
or over 17.
Over its opposite side. The
Yeah.
side opposite the 21-degree angle is AC. Okay.
And then that equals sine C over 32.
Okay.
Let me do that.
32 times that. What's that number?
Oh.
And in this particular case, I need a number because we need to check whether it's a possible ambiguous case or not.
Yeah. 0.6, oh, and then take the inverse.
Is it 0.6 something?
Yeah, 0.67.
Okay, so C is equal to
42.
Okay, now once again, since we don't know whether it's ambiguous or not, let's figure out the second possible. So what's the second angle that C could also be? Supplementary to 42?
138.
Now we add that to the only known angle, which is 21 degrees, and lo and behold, that sum is less than 180, which means we have two possible solutions.
Okay.
In one solution, this is 42 degrees, and we'll solve for the rest of it. Let's see.
Okay.
21, 17, 32. So I solve for this. Oh, and then I add this. Okay. The other solution, I'm going to draw it.
Oh yeah, now we gotta solve for height and stuff, right?
No, we don't have to go through any of that.
Or do we just split?
We don't have to go through any of that. Yeah. Just 1 second here. I'm confused because I'm used to looking at this in a different orientation here. Let's draw it in that orientation. I'm going to redraw this thing.
Okay.
Because it'll be easier for me to show you the ambiguous case.
Yeah.
I'm going to draw the same triangle, only this time I'm going to label it slightly different. Let's see. The angle we know is 21. I'm going to call that B. We know that's 17. We know that's 32. I'm going to call this C, and I'm going to call that A. So all I've done is turned it around. I've taken the picture. I've taken the picture you have drawn there and rotated it basically 90 degrees left. Oh,
Yeah.
no, I haven't. A has to be over here.
Oh, I see.
Yeah. This is A. No, then that's going to give me the same problem. No, let's just hold on. I don't know why I'm confused. Let me think about this for just a second. So we have B opposite the 17. That's proper. We have 32 opposite the C, and that's all we need. Okay. So that fits what we did. The sine of 21 over 17 equals the sine of C over 32. We solve for C. C can either be 42 degrees or 138 degrees. And this is the 42 degree one. Here's the 38 degree one. This angle is 138 degrees. Notice that everything else is the same. This angle is 21. This side is still 32. This side is still 17.
Okay.
In other words, this triangle over here fits the three parameters they gave us in exactly the same way as this triangle did. It's got the angle, side are the same. Yet, it's a totally different triangle. So in the first triangle, the third angle is what? It's 180 minus 63.
Yeah.
Is that 117?
Oh. 180 minus 60. Yeah, 117.
And the second triangle, this angle is, let's see, 21 and 138 or 159. That's 21 degrees also.
Wow.
It's correct. I haven't drawn it as such, but it's an isosceles triangle.
Okay.
Okay? Now, we still have to solve for both triangles. In other words, we're not done with the triangle on the left. So
We still got to get A.
we still got to get A, so I'll leave everything, I'll leave the sine of 21 over 17. There's our constant. And that's got to be equal to what?
Oh, sine of 117 over B, or over A, I mean.
Okay, so we can solve that triangle. I'll let you do that on your own. In the other triangle, we have solved for all three angles and two sides. So in the other triangle, I still have to solve for side A, and it's a different length. So we still, we still have the sine of 21 over 17. But in this case, it's equal to what?
Sine of 21 over A.
So A has to be 17. So those are the two solutions for problem 4. And
cool.
I didn't have to go through any of those rules about one of the sides has to be greater than the sine of the angle times the other side. In other words, all the stuff that they try to teach you about the ambiguous case of the law of sines is completely unnecessary. You don't need to know anything. I'll tell you, you need to know one thing and one thing only, and it's the following, is that as long as you have an angle that's less than 90 degrees, in other words, that can be anything up to 90 degrees, and you have this side and this side, or for that matter, this side and this side. No, not that side. You can only have the ambiguous case when you have side-side angle.
Mm-hmm.
But it doesn't matter if it's in this orientation or the other one where we have this side and this side.
Yeah.
Completely unimportant. As long as you have angle side, side, and this is less than 90 degrees, then always find that supplementary angle for the first angle you calculate. In
Okay.
other words, the first one we're going to calculate is always going to be this one here, right?
Yeah.
Well, that one there can be that answer, or it can be this one here.
Yeah.
And it all depends on whether that second angle added to this known angle are less than or greater than 180.
Okay.
If it's greater than 180, throw it away, use only the one solution. If it's less than 180, use it. All right, let's look at 5, because I want to cover one more situation here.
Okay.
That's important. In other words, in general, the law of sines and the law of cosines are pretty simple.
Yeah.
It's not a difficult thing.
No, it's not too bad.
The
I
only
think that's my favorite.
The only two parts that are hard are the ambiguous case and when it's not a triangle. In other words, when you have no solution. And you find that out when you get the sine of an angle as a number greater than 1. In other words, if I'm going through solving for using the law of sines and I come up with the sine of c equals 1.2, then that triangle can't exist. Because sine has to be less than 1, always.
Okay.
Any triangle, the sine of one of the angles is always a number less than 1. Sines and cosines are never greater than 1.
All right.
Okay?
As you see on the unit circle, too.
Right. So notice that in problem 5, we actually have the same situation. We have angle, side, side. However, in this one, we don't have to worry about the ambiguous case at all, because that angle is greater than 90 degrees.
Okay.
So help me solve it. What should I write?
Oh, 1 second. You do this sine of 98 over 29.
Yeah.
Equals the sine of A over 33.
Okay, so the sine of A equals 33 times that.
Yeah.
Give me a number.
Yeah. Let's see. It was over 1, so. I got 1.12.
Okay. 1.12. So this is not a triangle. You cannot have a triangle with these 3 measurements here. Good. Okay. Let's look at number 6. So we've covered the only 2 hard situations.
Okay. Let's see.
Everything else is just plug and solve. There's no conceptual problems.
So it's just going to be sine of 73 over 18 equals sine of B over 11. and then times by.
What's this number?
Let me get it 1 second. $10.5. Whoa.
It's not that.
Huh.
What's the sign of 73? The only reason I know it's not that is because I know this is a number less than 1.
Huh. 1 second.
So if you do it 2 steps, take the sign of 73 and multiply it by 11 divided by 18.
Yeah. I don't know why I keep getting the same thing.
Well, let me do it on my calculator. Sine of 73 times 11 divided by 18.
Oh, 0.58. I don't know why I was.
Oh, I must be in.
I was only doing 1 step. Sorry about that.
Okay, what was the answer?
0.58.
Okay, so B is what? Don't forget to allow for the ambiguous case. In other words, we need both angles. We need the first quadrant and the second quadrant.
All right. B equals 35.45. And then
notice that
144. Or yeah, 145.
so 145 added to 73 is way over 180. So we don't have an ambiguous triangle.
Okay.
Okay? And if you just always do that, every single time you have the conditions met for an ambiguous case, always figure out the second angle and see if that triangle could exist.
Okay.
So let's go ahead and finish it. We've got B equal to 35. I'm going to round everything off. This is crazy how they keep doing that. They shouldn't do that.
Yeah, no, I don't.
It doesn't make any sense at all. It makes you spend all your energy handling those 2 decimal points, which is crazy.
Yeah, and then you could be off
Yeah, I mean, what's the point
in
of
the
that?
final answer. Yeah, I had a question on my review and I was off by like 0.7 something.
Yeah. It doesn't make any, I don't know why they do it. They could make whole numbers out of everything. You still learn
Yeah, because it's
you learn the principle
it
exactly.
help you learn the principle even probably easier.
Yeah, exactly. Okay, so I've solved for all 3 angles. I need one more side.
All right. Oh, you need the
Side
opposite.
C.
So sine of C. Or oh yeah, sine of 72 over C.
Okay. Solve for C. All right, let me open up. It says that's all on this page now. Let me open up this other one, the one that says photo. Have you had law of cosines?
Yeah.
That's probably what.
0.95.
Okay. I figure once we get to this step, you don't need my help anymore. We should go on once we get there. I mean, you can figure it out later on your own, but we don't need a number there. In some of the ambiguous cases, we need a number so that we can determine whether it's an ambiguous case or not. Okay, so now they're giving us this situation.
Yeah.
Why have they drawn it the way they've drawn it? I don't know. I'm not quite sure. One of the triangles looks like this. What's this drawing here?
That was the other triangle.
Ah, okay. All right, let's talk about this situation. If that's one triangle, the other triangle is always that.
Oh, okay.
In other words, the big triangle is one triangle, this is the second triangle. It's not drawn. In other words, this is not the second triangle. You don't drop an altitude and make that your second triangle.
Okay.
What happens, basically, is you take this side, and let me label these, A, C, B. You take side A, and you move it clockwise to this line right here. Notice that this is still side A.
Oh.
And this angle is supplementary with this angle.
Okay.
So the second triangle would be like that.
Alright.
But the way I always think of it is, can you take this side here and draw it like that, making an isosceles triangle? And if you can do it, then you have two possible triangles, because this side didn't change here. In other words, that's 75, this is 35 degrees. Well, this is 75, and this is 50. Well, this is still 50, and that's still 35 degrees. So let's go through this one just to make sure. So let's solve this triangle first.
Oh, alright. I take the sine of 35 over 50 equals sine of B over 75.
Okay, and tell me what this thing on the left equals.
Let's see.
It's 1.5 times the sine of 35 degrees.
Divided by 0.86.
0.86?
Yep.
So what is B?
Oh, and then 59.31.
59, and what else?
Oh, and then 121.
And can both of them work?
Yeah.
Because we take that 121, we add it to this 35-degree angle, and it's less than 180. So this model works over here. And now solving the rest of it's easy. In other words, now one thing that might be a little confusing to you, it was confusing to me the first time I looked at this, was that the rules say that you only have to consider the ambiguous case if that angle is less than 90 degrees. Okay?
Okay.
And yet, one of the triangles that gets created is this triangle over here that has an angle of 121 degrees in it.
Yeah.
Does not matter. Don't let that confuse you.
Okay.
In other words, the only angle I knew, given the data that was given me, was this one angle of 35 degrees. That's the angle that cannot be over 90, if it's an ambiguous case. In other words, if this angle is 92 degrees, then I don't even need to check and determine what this other angle is. I wouldn't do it. I wouldn't spend the time doing it.
Okay.
Okay? All right. You can finish solving both of these triangles?
Yeah.
Okay. Let's move on to the next problem. Okay. I don't
think I might be it.
Oh, this second photo was the first one, so that's it.
Yeah.
Okay.
That's all I got.
So you're not into the law of cosines yet.
I'm pretty good at the law of cosines, actually.
Okay.
I have a whole. I got some notes.
There's only There's only two situations where you use the law of cosines to start. Only.
Okay.
And that's when you have side, angle, side.
And side, side, side.
And side, 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 exactly. The reason is because with neither of these do we have an angle and its opposite side. So we can't apply the law of sines to this situation on the left, and the one on the right, we don't have an angle.
Yeah.
So those two require you to use the law of cosines to begin, but once you've solved for one more piece of the triangle, then you go into the law of sines to finish.
Okay. Oh, yeah, that is how you do it.
Yep. In other words, you always have to use the law of sines. But these two cases, you have to begin by using the law of cosines.
Kind of like breaking it down.
Yeah. In other words, the law of cosines will give you this side. It'll give you side A.
Okay.
Okay. And then once you have side A, you have a side and its opposite angle, and you can then finish the triangle by using the law of sines. The first thing that you'll get is one of the angles using the law of cosines. Once you get that angle, now finish the problem using the law of sines.
All right.
Okay. What else? Anything?
I'm actually pretty good on all this stuff for right now.
Okay.
But I might need I might need 2 sessions next week.
Okay.
Just for review.
Well, let's look at next week here.
All right.
We got you down Wednesday. When else would you like? You have a test. You have a test coming up next week.
It might be on Friday, but I'm not sure.
Okay. Because I got more openings on Thursday than I do Tuesday. No, I got plenty on Tuesday. But I only have one tiny space on Monday, which I would prefer not to fill for the moment. Does one of these other days work for you?
Yeah, Tuesday works.
Tuesday works? Same time?
Or actually, could we do Thursday after that class?
Yeah, yeah. What time on Thursday would you like? Same time or different?
I can even do it early.
Well, usually I block this time off for lunch.
Okay.
If you could do it earlier than this, that's fine. Or you could do it sometime in between these two.
Okay, I'll do it at can I just do it at 5:15 again?
Yeah, I was going to say there's definitely an advantage in having the same time in terms of memorizing it. So I'll just move that down to there, and I will see you both days.
All right, sounds good.
Okay?
All right.
All right, Alex. I'll talk to you later.
Yeah, sounds good. Thanks for the help.
Sure. Bye-bye.